Well, hi everybody, my name is Mark Coe. I work at Spotify. I'm a backend engineer on the recommendation systems team. Spotify is a music streaming service, although I will not be telling you about music streaming today. I'm going to be talking more about code bases and things. And today I'm going to talk to you about how you can start being static with MyPy in Python. So today we're going to go over kind of what static versus dynamic typing is. I'm going to give you guys a quick pep talk, tell you what MyPy is, how you can add MyPy to your CI/CD pipeline, and some of my experience of using MyPy at Spotify. So let's start off by talking about static versus dynamic. There are definitely arguments for static typing and dynamic typing, but this talk in particular is going to tell you about the advantages of using static typing in Python. So before we get really into how to use static typing, I want to clear up some confusion. So static and dynamic versus strong and weak, there is a lot of the time some confusion kind of between what these things mean, and the terms are interchanged a lot, but they're definitely not the same. So when we talk about static typing, we are simply talking about when your code is checked when your types are checked at compile time, versus dynamic typing where your variable types are checked at runtime. So in static typing, you're going to see things like int x equals 1, string y equals banana, whereas in dynamic typing, you're just going to see x equals 1, y equals banana, right? And then strong typing simply means that your types will not be implicitly cast from one type to another, and in weak typing, they might be cast. So you won't implicitly cast an integer to a string or something like that. So static typing does not mean that you are a strongly typed language, and dynamically typed languages are not necessarily weak. And in fact, Python is a strongly and dynamically typed language. A lot of people call Python a weak typed language because it doesn't have int in front of the terms, but it actually is strongly typed. And it uses a flavor of dynamic typing called duck typing, which says, hey, if you have an object x, and x has a method y on it, Python doesn't really care what the type of x is. As long as it can call y, you can call y on it. And for those of you who don't believe that Python is actually a strongly typed language, here's an example to prove it. If you try to add banana to 3, you're going to get a type error. You cannot concatenate string into integer objects. Python's not going to convert that 3 to a string, and it won't work. However, in Java, conversely, Java is actually a weakly typed language. This will work in Java. You're not going to get an error. Java will implicitly cast that 3 to a string and concatenate it with banana, and you'll get a thumbs up from Java. It'll compile. Good stuff. So why are we actually talking about static typing in Python? Like, does it do anything for us? So for those of you who have worked on relatively large code bases in Python, you'll probably know that dynamically typed code bases become harder to maintain as they grow larger, and you have a lot of people collaborating on the same code base. In reality, PyDoc comments aren't really sufficient for telling developers that are working on your code base what your methods expect, what they're producing, what the side effects may be. And you can't be confident that when a developer updates a method or a class, that they are going to actually update the PyDoc documentation, and that everyone is going to conform to the same format of PyDoc comments. And Tim Peters said it himself in the Zen of Python. Explicit is better than implicit. And that's definitely true with static typing. Static typing is definitely more explicit than implicit. So here's an example of why we'd want to use static typing in Python, right? Python is pretty fickle. If you call functions improperly in Python, it can lead to really critical bugs. So here we have a class person with a method describe on it. Just prints out some useful information. Let's say we have a person object and we call describe. I've done this before. I fat-fingered the keyboard and I missed a letter. And this can ship to production code. You have nothing stopping you from actually putting this into production, and you won't get any errors until this line is actually hit. But when p.describe actually gets hit, boom, we get an attribute error. Person has no attribute describe. So if this was like a web application or an API or something, the response from the server is going to be internal server error, right? And that's really bad. We don't want that to happen. This is something that should have been checked beforehand. And sometimes it can be, right? There's a thing called pylint out there that says, hey, P is a person. I know what methods person has on it, so I'll check, and it'll tell you, hey, person objects don't have describe. But let's look at an example that something like pylint can't catch. So here we have a function foo that takes an argument a, and our PyDoc comment says that foo returns a version of the past string wrapped in parentheses. And when we look at this code, it looks a little bit weird. We know that the developer probably meant to put a.strip, which would take out any white space and make the parentheses wrapping really nice, but they messed up, they brain farted and put a.split, which in our case we know will actually return a list of strings. So when you run this in production or and run into this code, you're going to get, boom, type error, must be a string, not a list. And again, this is a fatal error. That's not good. Python is kind of fickle in this way. So I'm going to give you guys a little pep talk. And for those of you who don't know, PEP in this case means Python Enhancement Proposal. And it's how changes get made and approved upon by the Python Software Foundation and the Python open source community to allow changes to make their way into the Python core code base. So it all started back in 2006 with PEP 3107, which was an enhancement proposal for function annotations. Now, all function annotations allow you to do is add arbitrary metadata to functions. And so you can add strings or integers and stuff after your parameters, and you can add kind of function return annotations, so strings after your functions. And the important thing to note about PEP 3107 is that all it does is it defines a syntax for this metadata and a grammar for parsing it, saying, hey, you can do this in Python. Python won't yell at you when it runs into code that has like, a string afterwards. But this PEP was intentionally left vague. It definitely hinted towards using these annotations for static typing, but it didn't try to define a way to actually use these. Then we come into PEP 484, introduced by Guido van Rossum, our benevolent dictator for life. Long live he. And PEP 484 introduces a way to perform gradual static typing and type checking using the function annotation syntax provided by PEP 3107. So one thing that it is important that it outlines is that this type checking is going to happen offline and voluntarily. So Guido here is not trying to change how we use Python. He's not trying to make it an enforced static type language, but he's saying, hey, here's a way that we can perform static type checking in a standard way so that we can actually start to build static type checkers. And it looks something like this. So we have a function called greeting. You can say that the attribute that or the parameters that it accepts name is going to be a string, and that this function is going to return a string. So PEP 484 was inspired pretty heavily by a library called MyPy. Now, what is MyPy? MyPy is an optional static type checker for Python. The project is led by Yuka Letasolo, as well as Guido, and a bunch of other people from Dropbox, who Dropbox actually hired Yuka and Guido to work on this thing. So they are kind of sponsoring the project, but it's also being worked on by an open source community. And MyPy will tell you when you're doing bad things with your types. So when you're trying to call a function that accepts a string with an integer, and one thing to note is that it is still in development, right? It's pretty early in its life cycle, but it's come a long way since its foundations. Now, who in this room is using Python 3? God, thank God. Okay. If you don't have your hand raised, my people, the time has come. Python 3 provides a lot of advantages. Unfortunately, MyPy is only for Python, or is designed for Python 3. It will work with Python 2, but you need to run it with Python 3. It's time to change. If you don't understand why it's time to change, come talk to me after the talk. There are many reasons why it provides benefits. So let's talk about how you can actually start using MyPy. So here we have a function fib. It takes a parameter n. And if we look at the code, we can kind of figure out, OK, n is probably, or it expects to be an integer. And I see a yield statement in there, so it's going to return a generator of integers. All right, but I had to read through that function in order to know what it does. So if we use type annotations, we are going to see, hey, n is explicitly an integer, and fib is going to return an iterator of integers. So I don't have to do guesswork. I don't have to read the code. It's right there in the function definition right before me. So here's an example of how we can use this with MyPy. So let's say that we call fib with banana. we can then run MyPy on that file, and MyPy will tell us, hey, argument 1 to fib has an incompatible type string. It expected an int. So it's saying, hey, you called fib with a string, but you said that fib expects an integer, so this is bad, it's not going to work. And that won't work in, or it may not work in production if your code really does expect an integer. So here's another example. Let's say you're calling out to some function that returns a variety of types, maybe a string, maybe an integer, maybe an array. But we know that some func, when called with -10, or whatever we're calling it with in this context, is going to return a string. We can annotate the type of some value with type string in this little comment over here. And so MyPy actually is aware of those. And so when we call fib with some value, it's going to, again, tell us, hey, you're calling fib with a string, it expects an integer. There's also support for, with PEP 526, that supports a little bit of cleaner variable inline annotations, but that's only supports for 3.6, so this might be better suited for most cases. So let's revisit some of these, the examples that we gave before. Here we have person, we call describe. Now we can use MyPy and it tells us, hey, person has no attribute describe, maybe describe. So it can even try to kind of guess what you actually meant when you fat-fingered the keyboard. And it will, you run this before you deploy your code, and it will tell you that this kind of stuff is happening. The other example that we said before, Pylint and IntelliJ and stuff would not catch, here we have foo. So we are going to need to change this function to include annotations. So we'll update this code to say foo accepts a string, and it returns a string. And well, so before, when we were just using Pylint, Pylint doesn't know what A is if we didn't have an annotation, right? So it doesn't know that when you call a.split, it could return a string, it doesn't know. So it just kind of gives you the benefit of the doubt and assumes that you know what you're doing. MyPy being explicit will say, okay, well, we know that a string and calling split on a string is going to return a list of strings. So when we call foo with bar, it's going to say, boom, unsupported operand types for string and list. And again, this is caught before you deploy your code, ideally. And so this can give you your, some insight into how your code is going to be dangerous before you actually deploy. So MyPy supports a bunch of built-in types, right? Your classic int, bool, float, string, bytes, etc. But it also provides a new typing library that you can import into your code, and it provides a bunch of new fancy types. So we have something called any, which is just kind of, hey, this function can accept anything. It'll figure out what to do with it. Don't worry too much about it. Or this function returns, if you're being lazy, returns something. I'm going to annotate that this returns something, but I'm not going to tell you what it is. That's up to you to figure out. So you also have you can also do optionals, right? So now you can explicitly say, hey, this function, this parameter is going to be an optional. It can either be none or not. And if something's not an optional, right, you say it's a string, it's going to be a string. You will not be able to call it with none. So you know whether or not you actually need to check for that none case. You can also do lists and lists of specific types. You can provide the types for your dictionary keys as well as values, iterables, sequences. You can do union and say, hey, this function accepts a string or an integer or an array of bytes. You can use tuples and type your tuples. So if you have a function that expects a tuple with an integer and then a string, and you try to pass it a string and then an integer, it's going to yell at you. It's going to say, hey, this tuple is wrong. Go fix it. You done messed up. So you can also annotate your functions that don't return. If you expect that a function will always raise an exception, MyPy will do the check to tell you that it does in fact not raise an exception. Any strings, MyPy supports generic types. You can also wrap your types in single quotes for forward declaration. And you can also do aliases. So if you have a really long type, like a dict of strings to lists of dictionaries, and you don't want to retype that every time you are passing this thing around, you can just assign it to a variable and then use that, and you can import it and whatnot. And there's also more that MyPy supports. You can read the documentation if you're curious about the other types. Additionally, MyPy supports something called stub files, and stub files are used to annotate libraries that you don't own. going into a library's code locally and modifying the code to add annotations, the Python community is what we call a dick move. So don't go edit other people's code. If you really want to annotate a code base, go put in a pull request to that library. Otherwise, you can use a stub file, and it looks something like this. So if you are using sumlib, in this case, you create a file called sumlib.pyi, and then you can annotate all of the functions that you are using from that library. And in this case, I'm using libfunc and libfunc2. I annotate those types, those functions, and what's important to note here is that these dots are literal ellipses. So you don't need to waste your time copying and pasting all of the internal code for those functions. MyPy doesn't care, it just wants to know what the function type is so that when you call those functions or classes or so whatever it is, then it makes sure that you're calling them with the right types. So you can also use stub files to kind of lazily annotate things. If you don't want to have to go through and modify your whole code base, you can just use stub files and use any's everywhere. And while that's definitely not as good as going through your code base and effectively actually correctly annotating all of your types, it at least verifies that the functions that you're calling actually exist, which is better than nothing. You can also use stubgen.py, which comes with MyPy and will automatically generate stub files to kind of take some of the heavy lifting off of your back, and then you can go through and do the proper annotations off of there. So how can you actually use this in your CI/CD pipeline, if you have a CI/DC pipeline? If you don't, you can look at my example repo afterwards to see how to create one. So as it turns out, it's pretty easy to implement it into CI/CD. MyPy natively integrates with JUnit, Cobertura. It can generate HTML, text, XLST reports, memory and line counts. All you need to do is just call MyPy, and then on your source directory, you can pass in a bunch of flags for whatever you actually care about. And if all goes well, then your pull request will look something like this, right? All checks passed, thumbs up, you can merge. Or if you're more like me, it might look something like this. All checks failed, crap. All right, so I'm using Travis CI here. In that case, I would click these little detail links over here, and that would bring me to Travis, which would tell me, hopefully you guys can see this, MyPy examples, line 36, argument 1 to fib, has incompatible type string, expected an int. And tells you that it failed, thumbs up, I can now go fix that. So as I said, I work at Spotify, and I spent some time working on implementing this on some Spotify code bases. So why did I actually do this? Spotify externally is pretty much entirely Java-based. All of our external-facing services are written in Java and a microservice framework that we've written in-house called Apollo. And the arguments for this are that Java is more enterprise scalable from a performance standpoint, which unfortunately I can't argue with. In the vast majority of cases, Java is going to be more performant than Python. However, they also argue that Java is more robust because it has compile time error checking and type checking. It's easier to test because you don't have to make test cases for passing a function a string when it expects an integer. And it's more explicit because the function definitions and classes and everything just have the types that they expect right in front of your eyes when you go to look at the source code for them. We also are a microservice shop at Spotify. So we have a lot of small code bases that get passed around from team to team, right? You might one day just be kind of like handed a code base because some team dissolved and now has a new focus, and it's like, hey, you own this code now, figure out how to maintain the system. And when that crashes, Python can be pretty vague. You have to go through, you're like, why is this crashing? Does this accept a none? Does it not? Does it check for those cases? And you're gonna have to go through and read all of that code, which can be a lot of work on the developer supporting that system. And so one thing also to mention is that we do actually have a lot of Python internally at Spotify. For internal services, tooling, analysis, data pipelines, and things like that, Python is still a thumbs up. We have Django, Flask apps, a variety of systems written in Python. So there's still a lot of places that we can benefit from using MyPy and static type checking. And perhaps, maybe one day, once we cover these later 3 bullet points with static type checking, well, then maybe we can start using Python externally. So here are some of the good things that I found with using MyPy on our code bases. I found that smaller code bases and APIs were pretty quick to staticify. to add static types to. And especially with APIs, I found that it was particularly useful because now when people go look at that source code, they see what that type expects rather than having to look at PyDoc, which may or may not be accurate. I found that it promoted definitely better coding practices and more standards than just PEP 8. PEP 8 kind of says how you can use your PyDocs to say what types your function expects and what it returns, but this is even cleaner. It's definitely more self-documenting. The code is right there. You know what it expects and what it returns. It's gradual. So this is one important part of MyPy, is that it doesn't expect you to migrate your entire code base to statically typed functions all at once. Now you can turn on strict type checking, which will make sure that you have everything annotated that you can. But in the other case, you can still take advantage of dynamic typing. However, what I also found is that MyPy will kind of force you to stop using dynamic typing as a crutch. I found that in a lot of code bases, especially my own, I kind of pass around loosely documented dictionaries that I'm like, oh, get this out of there and put this in there. And I found that that's kind of how we use dynamic typing as a crutch in Python, right? Because you can have these really loosely typed dictionaries, you pass them around a lot and it's very easy. But when you're growing to a more enterprise level and you're trying to make your code bases scale, a lot of the time it can be more beneficial to turn these things into kind of actual classes, objects, even named tuples, so that it's a little bit more formal and more expected and it's known what you expect. So there's also no silent type switching, right? If x is an integer in the beginning of the function, it's going to be an integer at the end of the function. And I found that it also promotes more Java-like Python, which in an enterprise world can be a pretty useful thing. So some of the not so goods. MyPy and static typing definitely requires more code, right? You have to import this typing library and import your types. And you're going to have to go through, might need to break some of your function definitions into multiple lines. And big code bases, because of this reason, are going to take a lot of work. It's not going to happen overnight. MyPy is also still in development. You probably will find some bugs here and there. You should report them to MyPy if you have the time or are able to recreate them in a kind of isolated environment. But if you need a quick workaround, you can always just throw type ignore on your type checker, and if you're using strict typing, and you can avoid that bug. The MyPy also might force you to refactor your code. As I said, a lot of the time you kind of use dynamic typing in Python as a crutch, so it may force you to, I think in the end, make your code bases a little bit better and more robust by extracting your code out to classes and abstracting it to kind of more object-oriented methods. And you're not always sure what you're returning. If you don't want to actually have to dig down into your libraries that you're calling out to see what, go down the rabbit hole and see what they eventually return or what various types they might eventually return, you might just have to settle with, hey, I'm just going to return any from this because I don't know what the method returns. So I'll just deal with whatever it sends back. And I think this is the biggest drawback, is that Pylint can kind of catch many of the issues that MyPy can with less work. Pylint doesn't require you to change your code base at all in order to tell you that person doesn't have a method called describe. And so that can be something to evaluate, right? It's like cost, risk, benefit. And so to wrap this up, static Python in typing will definitely, in my opinion, lead to cleaner and kind of better documented code bases. It just takes a lot less work to figure out what everything expects. MyPy I found to be most useful for libraries and APIs that other people are using, because just easier to read and more accurate than PyDoc, and you can make sure that your library is in fact conforming to the specifications that you're writing in your types. And it's also good for larger projects where you have a lot of people collaborating on the code base. For smaller applications and code bases, Pylint may be sufficient if you just want a quick solution to be like, hey, do a dummy check on this code base. And especially if you're working on your own and it's not changing very much, Pylint is probably all right. But overall, my experience with using it at Spotify has definitely been a thumbs up. If you're working in the enterprise world and on large code bases, I would absolutely recommend it. I think that it will really help kind of prevent silly errors down the road. So here's some handy links. I have an example MyPy repo where you can see how to integrate it into your CI/CD pipeline, configure MyPy for different testing. You can see the MyPy GitHub. There's a great talk by Guido on type hints. If you are planning to approach your large code base and implement static types in it, then I definitely recommend watching this talk. And also a post from Zulip about them and their approach to implementing it on their very large code base. And I also want to say thank you to Spotify, not only for sponsoring PyGotham, but also for letting me come up here and talk about all this stuff. It's a great place to work, and we are hiring, so come talk to myself or anyone else out at our table in the sponsor fair area. And that's all I have for you today. Thank you for listening. Do we have time for questions? And unfortunately, we don't have time for questions, but feel free to come up to me afterwards or out in the sponsor area. Yep. It's break time, so go get some food and come chat. Thanks.